Hello and welcome to this talk, which is part of the symposium on animal consciousness in comparison to human consciousness at CogSci 2021. I'm Colin Allen, faculty member in the Department of History and Philosophy of Science at the University of Pittsburgh. And I start with these two images of a hawk that was resident in my backyard in the winter because they help illustrate a couple of things that are often discussed in the discussions of the nature of animal experience. For example, what kind of color vision do they have? Do they live in a monochrome world, as might be suggested by the right picture? But also, when we see the right picture with the hawk's face turned towards us, we see very clearly that it has forward-facing eyes, and that suggests to us then a capacity for stereoscopic vision, which would naturally be very important in an animal that makes its living by dive bombing smaller prey. Now, there are two questions one might ask here that I would like to distinguish. One is the hawk conscious at all? And the other is, what is the content and structure of the hawk's experience? And then for today, I'm actually going to elide the question of whether the hawk is conscious at all. I think that there's an emerging consensus that in some sense, consciousness does apply to animals. And I also believe that the way to go about making progress on this question is not to try to rebut all of the philosophical arguments that are sometimes put forward to reject the idea of consciousness in animals, but just to proceed to see whether we can accurately measure and determine such things as the content and the structure of the experience. So when I talk about content, then issues such as the first two I've already mentioned, color discrimination and depth perception, loom large. But also in the literature, people have tried to understand such things as multimodal object recognition. So do animals other than humans have the capacity to perceive an object in one modality and then select it using a different modality that they have not seen that object in before or touched that object in before, for example. But these are actually relatively static ideas about the content of animal consciousness. That is, what colors are there, what depth finding do they have, what are the objects in their environment, how are those objects represented. But an important question historically has always been the dynamical structure of the temporal structure of conscious experience, and that's what I hope to get to. So by taking this approach, I hope to steer us between these two very dangerous philosophical issues. On the one hand, the question of whether animals are self-conscious or self-aware. This is often a pinnacle on which we humans place ourselves as a way of separating ourselves from other animals. And on the other side, the black hole of qualia, which leads to rather complicated discussions and a lot of dispute about whether the notion of qualia even makes sense. And I'm lumping myself in this boat, steering between these two hazards towards a hopeful science of comparative consciousness, although you may think I'm one of the philosophers either trailing behind or maybe just shark-like waiting for something to fall out of the boat so we can get a good meal. Nevertheless, what I want to work towards here is a temporal psychophysics of animal consciousness. And so in the remainder of this talk, I'm going to give you a brief history of time and consciousness. I'm going to discuss some psychophysical approaches that have been applied in humans, but which rely on humans' ability to describe their experience, or at least relate it with words to some external events. And then I'm going to describe an experimental design that has been worked up in conjunction with Antonella Tramaceri, where we think it's possible to apply this psychophysical approach to non-human animals. So I want to give full credit to her for contributions to this talk. So a brief history of time and consciousness, and if we go all the way back to the beginning of the 19th century and the seminal work of Herbart, he tried to develop a mathematical model for the competition among ideas and the strength of ideas in consciousness. He, in fact, thought that such a mathematical approach was absolutely essential given the difficulty of actually doing good experiments, as he saw it, in human psychology. Nevertheless, the unmeasurable nature of this approach leaves us wanting more. And it was later in the same century that, of course, Weber and Fechner in particular started doing more to introduce an experimental approach to psychology. And also for them, the notion of, and for Fechner in particular, the notion of temporal dimension to consciousness and being able to correlate events as reported by subjects with things happening in objective time came about. And here we see an illustration of Fechner's pendulum, which was used in some of those experiments. In the 20th century, Lebet introduced a method of a clock with a moving dot that then could be used by subjects to state or identify when certain events in an experiment were occurring according to their own experience of it. So again, this depends on subjective report, but it provides a kind of measure of the correlation between the objective time, the clock going around, and the perceived time, the subjective report. Now, the early or late 19th century and early 20th century also sees a lot of interest in the so-called wave of consciousness, both when it comes to humans and when it comes to animals. So here, an illustration from Lloyd Morgan's textbook on comparative psychology, his illustration, or one of his illustrations of the wave of consciousness, which he explicitly acknowledges James for, describing what he saw as a peak in the present of some awareness of things in the environment, but that peak also spreads and contains things in the past to the left and some premonition of things to the future at the right. So this spread out nature of consciousness is what James referred to as the specious present. The idea that conscious experience itself is not point-like as physical time is, but is rather distributed somehow across our experiences in time. But this, of course, also turns out to be unmeasurable. But around the same time, or a little bit later, ideas about how to measure this without words in non-human animals began to be developed. And so at the bottom, I'm illustrating the phenomenon of flicker fusion, where a rapidly enough blinking stimulus is perceived as a stable object. But once the blinking drops below a certain rate, we see it as flickering. And it was known to von Uexküll and others that, for instance, many birds, pigeons, had different flicker fusion rates from human beings. In fact, they perceive flickering at faster rates than we do. And this led von Uexküll also to try other sensory modalities. So as an illustration of an experiment that he describes of a snail that's crawling on a ball that's floating in water, so the ball can just continue rotating as the snail crawls. And he describes tapping the underside of the snail at a certain rate and finding that once that rate fell below 2 or 3 taps per second, the snail would stop moving. But if the snail experienced taps at a rate above that, then it would continue crawling, apparently perceiving the solidity of the surface, or the surface that it was moving towards as solid. And so these experiments give us some hope that a kind of psychophysical approach might be taken. But again, notice that the delivery of these, although they use time in the experiments and tell us something about the temporal structure of consciousness, are really, in the end, telling us about the nature of the content, right? The stable object that is perceived. I'm going to turn now to some recent experiments with humans that give a suggestion about how we might proceed with animals. And this is into the phenomenon that's come to be known as temporal binding. And initially, as described by Haggard, Clark, and Kalogeras, the experiment was for subjects to experience a finger movement, either under their own voluntary control or under transcranial magnetic stimulation, and that thing then being followed by a tone. So on the left here, you have a description of the part of the experimental procedure. There's a Libet clock. In this case, the human is going to make a voluntary key press and is supposed to note the time on the clock at which he or she does that. And then comes the tone at some 250 milliseconds delay. and then they're supposed to report where the clock is when that tone comes. And the basic finding in the bottom right here is that under conditions of intentional agency, the subjects experience a subjective shortening of the time. They report the action as occurring later than it did, and they report the effect as occurring earlier than it did. So this is a kind of temporal binding that's then split into action binding and outcome binding. More recent work went on to show that you could get this binding effect even without the intentional action of the individual. And so these use virtual reality and experience of an event that is taken to be understood to be a cause-effect relationship produces this kind of binding. And here's another experiment from Bühner in 2012 in which subjects either, line B there, push a button on a machine and then some delay of up to 5 seconds, some variable delay occurs, and then the machine eventually presses a button, or they press the button directly themselves, and then some other event occurs as a consequence, with some delay of half a second or up to 1.3 seconds, or they just get the same interval between seeing the first stimulus, the button flash, and the tone, and finding that you get temporal binding in either the machine-mediated or unmediated cases, but you don't get it in the case where no action was involved, either of the individual or the machine. So again, this is a verbally dependent protocol. And so Antonella and I have proposed an experiment under review at the moment in which we look at non-human animals and modify the situation in the following way. First, we consider pre-training the animals, in which the two animals who are going to be yoked subjects eventually experience the same training, and they are presented with a pair of tones or a pair of stimuli at some interval that's determined by the experimenter, and they're trained to feed in one place if the interval between those two tones is below a certain threshold, and they're trained to feed at the other location if it's above a certain threshold. And then once they've got this training, they're put into an experimental situation where the yoking matters, where the first animal now has a button introduced, and its pushing initiates the two stimulus sequence. So it presses the button and tone 1 appears, and then at some delay determined by the experimenter, tone 2 appears, and then they presumably go and feed according to their previous training. The yoked animal has no button. It doesn't see the primary animal. It simply experiences the same delay that the primary animal did. So it gets tone 1 when the primary animal took an action, and it gets tone 2 when the secondary animal gets, when the primary animal gets that same response. And the proposal here is that if we found that we've got temporal binding in the primary animal, but not in the yoked, then we have a psychophysical method that works without words. So taking this experiment and interpreting it, we would argue that temporal binding reveals that the subject's perception of time is different from the experimenter's objective time. This is a kind of temporal illusion that has been used to inform theoretical claims about awareness in human subjects. And the psychophysical approach provides a way into how things appear to the subject. So we have a wordless method which opens up the space for comparative investigations of consciousness of time and causality. So if we take that back now to Morgan's images, so here are the 3 images that he actually provides of this, showing the same wave from different angles. The shape of this is something that perhaps we could study by further adapting this method. So in particular, if we could vary the cause-effect response latencies within an experiment such as this, we may be able to reveal asymmetric structure in subjective time. So for example, different action and effect binding effects could occur between the causal and non-causal contexts, depending on where the cause-effect are related at different points of this curve. So with that, I hope to have convinced you that there's hope for a psychophysical approach to understanding the temporal structure of consciousness in non-human animals. And I look forward to your questions. Thank you.